ఒక్క నిమిషం అండి. Okay, now in today class we will discuss the applications of, our topic is applications of line integrals. So applications of line integrals. I think in the starting class I have given homework to you, just to note down 10 applications of vector differentiation as well as vector integration. How many have done? How many have list out? ఎంతమంది రాశారా, ఎంతమంది నోట్ చేశారండి లిస్ట్? హారిక, రాఘవేణి. Okay. So now today we will discuss a few applications of line integrals. The first one is, suppose if f be a vector and this is f is a force field, and here f is equal, we are assuming f1i plus f2j plus f3k, and so then the total work done by this force field F as particle moving. So particle moves from the point A to B, from A to B, that means from the curve A to B, from the point A to B along the curve C, is given by integral A to B f dot dr. It is equal to W. That means work done by force. So work done by force is line integral. So W, it is equal to integral C to f dot dr. So this is the one of the application. Okay. Now what is the second application? So this is the first application, and the second application, number 2. Suppose if f denotes velocity of fluid, then the line integral C is called as a circulation of this f around a closed curve. So this is the second application, and third one is the scalar potential field. So what is the definition of the scalar potential field? Last class lo discuss చేసినట్టున్నాం. Anybody? Scalar potential field. What is the definition of the scalar potential field? ఓ మై గాడ్, గుర్తున్నాయా అండి డెఫినేషన్? So given vector f, vector point function f, if there exists a scalar point function pi such that this f is equal to, suppose the gradient of pi, or f is equal to del pi, then this pi is called as a scalar potential. So scalar potential of the given vector f. So this is the definition. Okay, and I think we have seen the properties of this scalar potential field also. What are the properties? గుర్తున్నాయండి properties? త్వరగా, మై గాడ్, త్వరగా చెప్పాలండి. లాస్ట్ క్లాస్ చెప్పినట్టున్నాను స్కేలార్ పొటెన్షియల్ ఫీల్డ్కి. గుర్తున్నాయి? If f is f1i plus f2j plus f3k and pi is equal to, f is equal to gradient of pi, then the curl of f must be గుర్తున్నాయా లేవా? Yes, the curl of f must be 0. That means f must be irrotational vector function or vector field. First point. Second one, converse. If f is irrotational vector function, or del cross f0 or curl f0, then definitely there exists a pi such that f is equal to gradient of pi. So this here and here pi is called as here the scalar potential of f. It is the second point. Now what is the third point? Third point gurtunda andi. Third and fourth point important for these problems. Third,
if f is equals to f1i plus f2j plus f3k and phi of f is scalar potential field.
If f is equal f1i plus f2j plus f3k and f is equal to gradient of pi, and pi is the scalar potential of f,
then f1 dx plus
f1 dx plus f2 dy plus f3 dz is an exact differential equation. Very good. And moreover in this one again here I am writing the sub, ఇక్కడ మళ్ళీ సబ్ ఎర్ వస్తుంది, సపరేట్ వద్దు. And we have the necessary and sufficient condition f1 dx plus f2 dy plus f3 dz is equal to 0 is an exact differential equation. What is the necessary and sufficient condition here? Necessary and sufficient condition. Dou f1 by dou y is equal to dou f2 by dou x, first one, and dou f1 by dou z is equal to dou f3 by dou x, and the third one, dou f2 by dou z is equal to dou f3 by dou y. This is the necessary and sufficient condition, so definitely. Okay, and the curl of 0, okay. ఇంకేమి ఇచ్చామండి ఇందులో? ఇంకా ఉన్నాయా? త్వరగా అండి. Okay, now here one more point, it is the new point. Suppose if the line integral is path independent, then definitely, that means suppose assume like this, integral f dr. Suppose here there is this path, suppose assume independent path. So definitely this f must be is equal to gradient of pi. Definitely that f is the, for that f we can write the gradient of pi, and the pi is the scalar potential field if the path suppose independent. Okay, that means what is that means? Curl f must be 0, or del cross f must be 0, or del f means here del pi must be 0. Okay, so this is our fourth point. Now come to the fifth point. So before going to the fifth point, now again I am revising the previous. Now if f is equal to f1 I plus f2 j plus f3 k, and f is equal, suppose I am writing the gradient of pi, and where pi is the scalar potential field, what about that mean? According to the previous one. Okay, ఇక్కడ ఇంకొక పాయింట్ రాయాలి, మర్చిపోయాను. So here I am writing one more point. So point C, this f1 dx plus f2 dy plus f3 dz, we can write d pi. Am I clear? Because already we know that this one is the exact differential equation, and pi is the scalar potential field. So the differential equation we can write, this exact differential equation we can write d pi. Now that means this, if it is like this, we can write d pi is equal to f1 dx plus f2 dy plus f3 dz. We can write like this. Now come to the here. Then now if suppose I have the integration of f dot dr, then what is the result? Observe, this whole I can write f1 dx plus f2 dy plus f3 dz on path C, and already we know that f1 I plus f2j plus f3k, and f is the gradient of pi, and the d pi is equal, we can write f1 dx plus f2 dy plus f3 dz. Thus this total you can write derivative of d pi only. So this is the result. Am I clear? That means suppose if pi is the scalar potential field and the line integral of f dot dr, we can write directly the result is pi only. That means no need to solve. Am I clear? Or you get my point?
Yes, sir.
So this statement I will write in another way also. That means integral f1 dx plus f2 dy plus f3 dz is independent path independent of path C if and only if this f1 dx plus f2 dy plus f3 dz is must be exact differential equation. Exact differential equation. So simply చెప్పాలంటే just no need to integrate if it is suppose path independent. Just apply the scalar potential, will get the result. Okay, so this one is the point. So this is the most important for solving line integrals. But first of all you have to identify whether that is related to curl f. Okay, simply suppose if suppose f is suppose irrotational vector and directly irrotational vector, the integration of f dr we can write pi only directly. Okay, so this is the most important property. Next one more definition. After definition we will solve the two problems, then we will stop. Okay, so the next definition is conservative field. Okay, so before going to the definition, suppose a vector field f is said to be suppose if its line integral does not depends on on the particular path, it's only depends on only endpoints, depends on its endpoints only, end points. That type of vector field we called as conservative vector field. Conservative vector field. That means suppose here there is a path, suppose it is the A and B. So it is the A point and B point. Suppose it is a path, and from the point A to B we will get some result. I am taking the one more different path like this. Suppose if the results is same by taking any path, so that type of here vector field we call as conservative vector field. So conservative vector field. And here the necessary and sufficient condition for the conservative vector field. So note number 1. So the necessary and sufficient condition for the conservative field. Necessary and sufficient condition. Necessary and sufficient condition is if F is conservative field, if and only if curl F must be 0. Curl F 0 means whatever that mean. Cheppali. That F must be irrotational vector. Okay, that is the necessary and sufficient condition. Or one more point here, according this one, if it is suppose conservative field, and according the irrotational. So irrotational means whatever that means. So if it is the irrotational, F is the irrotational vector, whatever that mean, if and only if there exists a pi such that F we can write gradient of pi. That means if it is suppose conservative field, definitely there is a scalar potential. Or you can write like this: if F is the scalar conservative field, definitely if and only if pi is scalar potential of F only. Okay, it is our second property. Okay, simply just if it is the conservative field, just to verify the curl F 0 or not. If curl F 0, that is the irrotation vector conservative field. And how can you write? So if you know the scalar potential, so of this F, so that F must be the conservative field or irrotation vector. Okay, so anyway we will solve the problems. These problems already is over. Ikkada solve chestunnattunnam. Yes. Okay, so this is the first question. In the previous class we have seen. Okay, and then first question, I think in F is equal 2xy plus z cube I plus x square j plus 3 z square k is the irrotational vector and find its scalar potential field. Okay, same question malli solve chestunnandi, don't confuse. Okay, but small modification. So this is the first question. So first question, ఒక్క నిమిషం. Okay, first question. Okay, show that what is the previous question. So before going to the solve this one, now we'll see the previous question. What is the previous question? Okay, in the previous question, so show that this one is irrotational vector. Irrotational vector means just show that the curl F 0. Okay, so already we proved. And find its scalar potential field also. Scalar potential field already we know that. Now pi is the scalar potential field of F and F is equal gradient of pi. According to that, now we are getting pi is equal to x square y plus x z cube plus c is the scalar potential of this F. Okay, this is the previous question. Now here I am modifying this question. So in place of irrotational vector, here I am writing So here the question is, show that this vector f is conservative field. Conservative field, that means just find the curl f and the curl f 0. So the given vector now conservative field because curl f 0. Okay, that is the first question. And anyway it is the conservative field, so and find its scalar potential. So scalar potential, so in the previous class already we did. Now let us assume pi is equal to, so pi is the scalar potential of f and f is equal to here the gradient of phi, or f is equal to del pi, and according to the previous one, d pi is equal to dou pi by dou x into dx, dou pi by dou y into dy plus dou pi dou z into dz, and dou pi by dou x after using this gradient of pi. Now gradient of pi, we are getting dou pi by dou x is equal to 2xy plus z cube, and dou pi by dou y is equal to x square, and dou pi by dou z is equal, it is the z, dou pi by dou z is equal to 3z square x. Now substitute, after substituting we will get here the pi is equal to x square y plus 2z cube plus c is the scalar potential. So this is the our result. Now here I am adding the question. Now it is the first question. Now the second one is, so second one is, and also find work done in the moving particle from point 1 comma minus 2 comma 1 to 3 comma 1 comma 4. That means what is the question? Just find the line integral. So line integral from the path 1 comma minus 2 comma 1 and 3 comma 1 comma 4. So this is the question. Now we will solve the problem. So now what is our question here? Third one. So work done by force F is whole integration of f dot dr. But what is our f? Already it is clearly given. What is the f? F is equal to 2xy plus z cube I plus x square j plus 3z square x into k, and dr we know that x di plus dxi dyj plus dzk, and already we know that d pi is equal to f1 dx plus f2 dy plus f3 dz. Now come to the question. Now in this question, so this whole integration of 2xy dz cube into dx plus x square dy plus 3z square x into dz. And what is our path? We are getting the path. Now path is from 1 comma minus 2 comma 1, 3 comma 1 comma 4, 3 comma 1 comma 4, but already we know that the whole part we can write x square y plus x z cube according to the previous one. What is the previous result here? This whole part we can write derivative of x square y plus x z cube plus constant. That means this whole result is x square y plus x z cube. Now just substitute x is equal to 1 to 4, 1 x value 1 3, x value is 1 2 3, and y value is minus 2 to 1, and z value is 1 to 4 in this results. Now upper limits. What is the upper limit? Just substitute x values. What is the point? 3 comma 1 comma 4 upper limit, and lower limit 1 comma minus 2 comma 1. Now substitute the upper limit. What is the upper limit here? 3 square into 1 plus 3 into 4 cube whole minus, so x square, that means 1 into minus 2 plus 1 into 1 only. So here we'll get 9 plus 3 into 64 minus of minus, so it is minus to minus 1. Now what is the result here? The result here 9 plus 64 into 3. What is the 64 into 3 value? 64 into 3.
192.
192. Very good. So 192 plus 1. So it is total 292 is the result. Okay. So here we are not solving directly line integral. So by using the scalar potential field, already we have the result. Anyhow, this is the exact differential equation. This is the exact differential equation. The differential equation will write derivative of some function. That means directly integrate. So in the integration of this whole function is x square y plus x z cube, and just substitute the upper limit and lower limit. Okay, am I clear? So now this is the work done by force. Force field here 2x y plus z cube I plus x square j plus 3z square into k. Okay, and this is the conservative field. Okay, Nandi. Now what is the second problem in the previous class? Previous class means second problem in the scalar potential field. Second problem. Verification already we done. This is the second problem. The second problem show that this xy square plus y cube I plus x square y plus 3xy square is irrotational vector, and also find it is the scalar potential field. And one more question here I am adding. So it is the ninth problem, ninth and ninth. Okay. Now this problem we will solve again. Okay, now come to the first question. Sorry, second question. Show that the given vector is conservative field conservative field. That means you have to prove that the curl of this f must be 0. So curl of f 0. So this f is now conservative field. Now what is the second question? And also find its scalar potential field. So scalar potential field, that means let us assume pi is the scalar potential field of f, and that means the gradient f is equal to gradient of pi, and the d pi is equal, we know that f1 dx plus f2 dy plus f3 dz, and already here we are getting our pi is equal to xy square by 2 plus xy cube plus c is the scalar potential field. Now here I am adding one more question here. What is the line integral of, now the next question, and also find f dot dr in the direction of, ఒక్క నిమిషం అండి, only two variables. Okay, so find the line integral and here the curve is path from the point 1 comma 2 to 3 comma 4. Okay, so now we'll solve. So scalar potential field already we are getting, so pi is equal to xy square by 2 plus xy cube plus c. Now in this sub question, third one, what is the third question here? Third one, line integral f dot dr, and what is the our f is equal to here, what is the given f, xy square plus y cube into dx plus x square y plus 3xy square into dy, or sometimes the question is they will ask like this, integral and the path c. So c is from 1 comma 2 to 3 comma 4. That means the same question they will ask like this, integral 1 to 2 to 3 to 3 4, and x y, sorry it is I and j. So xy square plus y cube into dx plus x square y plus 3xy square into dy. Okay, so they will give the question like this, but already we know that what is the result according to the previous one, this xy square plus y cube dx plus x square y plus 3xy square dy is equal, we are getting the total result is, what is the total result, x y whole square by 2 plus xy cube plus constant, will get the result like this. So directly here, now integral a to b f dot dr is equal integral 1 to 2 3 comma 4 and x y square y cube plus y cube into dx plus x square y plus 3xy square into dy. So now this is the it is the this differential equation, now exact differential equation. The result we will write like this, xy square by 2 plus xy cube and the limits 1 to 2 to, so 1 to 2 3 4, and upper limit is 3 4 and lower limit is 1 to substitute, upper limit is 3 4, 3 into 4 whole square by 2 plus 3 into 4 cube for upper limit, for lower limit x is equal to 1 and y is equal to, so 1 2 whole square by 2 plus 1 to cube. Now here 12 whole square. What is the 12 whole square? 144. 144 by 2 and 3 into 64. What is the 3 into 64 value? So 3 into 64 minus for lower limit 2 plus 8, that is a 16. So 72 plus 3 into 64 minus 10. What is the result? CS? So the result is 254 is the result. Okay. ఓకే క్లాస్ కంటిన్యూ చేయాలండి ఆపేయాలండి? హలో హలో
కంటిన్యూ చేయండి సార్.
హలో సార్,
ఆపేస్తున్నానండి.
ఆపేయండి.
హలో ఎవరు
ఓకే
రెస్పాండ్
సార్.
ఇవ్వకపోతే నేను ఆపేస్తానండి. ఓకే ఓకే, ఐ విల్ స్టాప్. థ్యాంక్ యూ.
సార్ హోంవర్క్.
హోంవర్క్ సో హోంవర్క్ అనేది నెక్స్ట్ క్లాస్ చూసుకుందాం, సరేనా అండి? సో ఆల్రెడీ స్కేలార్ పొటెన్షియల్ ఫీల్డ్కి సాల్వ్ చేసిన కొన్ని ప్రాబ్లమ్స్, 3 ప్రాబ్లమ్స్. సో దాన్ని హలో ఎక్కడ ఉన్నా?
ఎస్ సార్.
సో స్కేలార్ పొటెన్షియల్ ఇన్ 4th క్లాస్ అండి. సో ఈ ప్రాబ్లం జస్ట్ మనం లైన్ ఇంటిగ్రల్ సాల్వ్ చేసుకుందాం. సేమ్ నెక్స్ట్ ప్రాబ్లం. వాట్ ఈస్ ద నెక్స్ట్ ప్రాబ్లం? దిస్ వన్. ఎస్. సో హియర్ ఆల్సో జస్ట్ ఫైండ్ ద లైన్ ఇంటిగ్రల్. So line integral of f dot dr. Okay, so that is the homework. Okay, anyway I will stop now. Thank you to all.
థ్యాంక్ యూ సార్.
ప్రాపర్గా రెస్పాండ్ చేయండి, లేదంటే నేను డైరెక్ట్గా ఉన్న వీడియోస్ని పోస్ట్ చేస్తాను. ఓకే, ఇట్లా ఆన్లైన్ క్లాసులు. ఓకే, వింటున్నారు? సిఆర్స్ వింటున్నారా?
అర్థం కాలేదు సార్.
మీరు రెస్పాన్స్ సరిగ్గా ఇవ్వలేదు అనుకో, ఆల్రెడీ వీడియోస్ రికార్డ్ చేసి పోస్ట్ చేస్తాం డైరెక్ట్. వింటున్నారు?
ఓకే సార్.
ఎందుకంటే ఇది 2-వే ప్రాసెస్ ఉంది. 1-వే ప్రాసెస్ ఉంది అనుకో, డైరెక్ట్ నేను ఇలా చెప్పడం డైరెక్ట్గా రికార్డ్ చేసి పోస్ట్ చేయాల్సి. ఆల్రెడీ వీడియోస్ చాలా ఉన్నాయి. ఆల్రెడీ మీకు ఆల్రెడీ ఇంతవరకు పోస్ట్ చేసినట్టున్నాను. వెక్టర్ డిఫరెన్షియేషన్ వేరే వీడియోస్ అలా పోస్ట్ చేస్తాను. ఓకే, మీరు ప్రాపర్గా రెస్పాన్స్ ఇవ్వకపోతే. వింటున్నారు?
ఓకే సార్.
ఓకే, ఐ విల్ స్టాప్.